Welcome to my talk about what to consider before simply lifting and shifting everything to the cloud. Just before we start, I'd like to explain what the term lifting and shifting is. Lifting and shifting is a term used to refer to the practice of simply moving IT infrastructure directly to a cloud provider. The IT market has a number of tools and services that assist with this approach. I would like to encourage you to review the ideas in this presentation before you go down the route of simply just lifting and shifting. My name is Darren Gipson. I work for Willis Watson as a DevOps engineer in one of our product teams. When I moved into the role of DevOps engineer in our office, we were beginning a project to migrate all of our aging infrastructure to Azure. The migration was a key IT strategy, and our business was pushing this down to all of our product teams. I was one of the key members of the team to architect our end solution and help choose the configuration management software for our department to help us with this approach. From the beginning of the migration work, we realized that instead of our current infrastructure was not sufficient enough for our current demands, yet alone the future visions for our product. So I put this talk together to explain how we, by simply not choosing to just lift and shift our servers from premise to the cloud, it has allowed us to provide a reliable, scalable, and adaptable setup for our engineering and product teams. 32% of IT budgets will be dedicated to the cloud by 2021. So there's no denying that more and more workloads are going to be moved to the cloud because enterprises do not want to be in the position of running their own data centers. Enterprises of more than 1,000 employees are investing on average of $158 million on cloud infrastructure and applications this year alone. That number is set to grow, according to Forbes. So I've put together 5 core reasons why I think you should consider a move to a more sophisticated approach rather than just lifting and shifting everything to the cloud. The first one is to standardize. Making key efforts to standardize the approach of new deployments will allow your engineers to deploy environments and applications quickly. It will increase the familiarity of the similar systems and environments and increase the amount of consistency in your infrastructure. Many servers have a fundamental base. They have a data disk, a paging file, and key applications installed on them. The problem is that they're often built over time by many different people with standards that have changed over time. Why, when you have a chance to start a fresh migration, would you miss the chance to rectify that? By introducing a templated approach to the deployment of your infrastructure, you're able to build it up again in a more usable manner. For example, one of the things that we did early in our Puppet journey was to puppetize the enrollment of disks on Windows boxes. This meant that anytime we needed to deploy a server with a disk, it was created in the same way, using storage spaces, giving us the building blocks to use again and again, whether it be file server, SQL box, or an application server. All the engineer really needed to do was include the Puppet disk class with the right drive letter. This also meant that it was a very easy way for expand the volumes, as the code was built in such a way that the only action the engineer needed to do was to extend the drive, was to add a disk to the server on the cloud portal. No need to log in, just wait for Puppet to run the next run. If we had simply just migrated the servers across without these building blocks, it would have made the creation of new servers just as cumbersome and not as consistent. As another example, we realized that a number of our servers were built such a long time ago that we didn't have a complete understanding of how they could be rebuilt. We could only rely on their VM image, so we embarked on a work stream to create templates of servers with Puppet, so that we had a record of what was required in the event of a necessary rebuild, therefore removing our legacy technical debt. We have utilized infrastructure as a code as a forefront for all server building as the point of migration. This way, we can easily replicate our infrastructure. And lastly, by taking this approach, we would no longer require VM backups, which has saved costs, which is an important part of the work that we've done. Scale. One of the key aspects of the cloud is that there is no real limit on size, big or small, other than budget. Please do remember this when you look at your migration plans. You do not need to get it right first time. You can always scale up and down. When we built infrastructure in the past, we needed to consider the availability of the hardware that we had available. Even in a virtual server setup, there were still rack limits and noisy neighbors to consider. Or in some cases, it could be that IT gave us a t-shirt size of machines mapped to cost, so a server was simply created to match that t-shirt size. We were also charged on a monthly or quarterly basis, so there's no real point in turning a server off. This meant that when we designed our infrastructure, we did those with these constraints. None of this was really true in the cloud. The number of t-shirt sizes is far greater. The size of the disks is no longer limited by the SAN, and more importantly, given that we don't use the resources all the time, we could simply save cost by turning the machines off when they're not in use. So why not take the time at the point of migration to review the machine sizes that you are going to use? Can you get away with the smaller machine size? We've used the scalability of the cloud to our advantage with the migration work. We've scaled up to test how our application copes in demand scenarios. We've turned servers off at night. We've added in new automation start-stop processes on our large worker nodes, and we've utilized burst machine types for resources that need to be on all the time, but not always in high demand. All of these have been wrapped around the reducing of costs. Do remember that on-premise corporate cost charging does not take into account when a machine is on and consuming resources. It does it over a sustained period of time. In the cloud, you're often charged by the minute or the second. Fun fact, in Azure, if you have a server on core hours of the workforce, say 12 hours a day, 5 days a week, you could save as much as 64%. Or put it another way, you could run 3 times as many of those servers during core hours for the same cost. Upskill. Staying relevant requires learning. This is a great quote, as it's true no matter what profession you're in. There are many different aspects to cloud deployment, and there are lots of things to learn, so seize this chance to give your employees a chance to expand. One of the key aspects of the cloud is it is different to that of on-premise. There are lots of terms which sound familiar that are not, and there are lots of new terminology that you need to understand. If you simply just lift and shift the resources directly, you could end up paying more than you need to, or you could end up leaving your resources exposed to the public internet. The former takes into consideration about the different sizes of compute, storage, and data center services available through the cloud. Each have their own benefits as well as costings. And the latter is extremely important. As recently as just June this year, Computer Weekly reported that the cosmetics firm Avon had been found guilty of leaving a virtual machine exposed to the internet with the public IP, a mistake that's too easy to replicate without the right precautions. Moving to a cloud service is a fantastic chance to learn something new and give your staff the chance to learn and further deliver their development. This process can take time, but you'll start to see the possibilities available to your business that were just not there before. We've provided our teams with access to Pluralsites and given them the opportunity to pass certification exams in cloud-related technologies. We've also highlighted key champions in areas of our cloud strategy, encouraging individuals to engage with these champions when architecting new environments. Modernize. Take the time at the point of migration to move services and applications to newer platforms when you do the migration to the cloud. Ask the question, does this system really need to continue on that operating system? When I started my role as a DevOps engineer in the product team, we had a Windows 7 build VM that for every 3 months would refuse to boot. And the only solution was to restore it to a snapshot that someone had taken 2 years previously, simply because the OS refused to update. This was an expensive piece of unplanned work that cost us production time. So as part of the migration work, we made sure that we moved to the latest operating systems. If you simply just lift and shift your virtual machines from on-premise to the cloud, you are simply pushing a further problem into the future and creating technical debt. By taking the opportunity to remove the older reliant software, you're reducing the later work, which can derail a future project deadline. This is really important. I cannot stress how nice it was to have a conversation with our IT team when they told me that Windows 7 was going out of support. And what was my plans for decommission? My list was so small that I could simply delete them. The server identities had been transferred to Puppet, and all I had to do was redeploy to Azure on the OS that we wanted. Some requirements may no longer be necessary. You can use this opportunity to remove legacy software from your infrastructure. This helps reduce risks in the future and reduces your maintenance overheads. Consolidate to simplify. Take the opportunity of the migration to take stock of what you have and whether you need to continue using the same resources in the cloud. Migration is often a disruptive process. Is it worth going through 2 different migrations when you could do just one, which involves the consolidations? Going back to the point about scale, this comes down to play when we're evaluating what you need in the cloud. You no longer need to worry about ensuring there is enough of a resource available to host resources on the same network. So take this opportunity to consolidate. Part of our migration to the cloud was to remove the need to have resources in different data centers or networks. By moving our resources to a single data center or cloud region, we took the opportunity to remove infrastructure which was created purely to support the multi-data center model. As an example, for us was the variety of different documentation tools. We used the process of migration as an excuse to consolidate our documentation tools across the department down. This reduced our technical costs, as some of those applications were only known to a number of small key workers. Both of the documentation tools we migrated are now SaaS-based, further removing the need to manage the software and physical infrastructure, saving vital engineering time. To recap, standardizing your deployments through server templating and build blocks for reuse later. Let these be the forefront of your design. Use scaling to your advantage. Does that server need to be that big? Can you turn off servers in non-core hours to save costs? Do review your machine sizes. Are they still relevant? Upskill and give your staff the opportunity to expand. Do this through online courses, certifications, and cloud champions. Take the opportunity to modernize to newer software. Remove the legacy technical debt so it does not derail future planned work. Realize cost savings by consolidating common resources that are no longer required. Take the opportunity to consolidate to a single toolset for common services. Why is this important? By 2023, 90% of enterprises will fail to scale to DevOps initiatives if they do not create a self-service shared platform. In our department, we saw that in order to achieve a successful cloud migration, we needed to give the ability of our engineering teams to self-serve. We did this by creating a shared self-service platform, providing a digital toolbox of infrastructure and capabilities to help our multiple DevOps teams create, release, and manage products, while ensuring consistency and streamlined efforts at scale. We made the management of infrastructure of cost the product team's responsibility and given them visibility of what each resource is costing, as they have the control to create and decommission the resource assigned to them in the cloud. By taking all of these things into consideration, we've been able to increase our speed of deployments. When a sales member asks me for a new environment to help design a product, I can now provide this in half a day. This used to take us over a week. They now have the luxury of telling me how big they want the environment, or if they're unsure, we can use post-deployment testing to tweak its configuration. Having a standard approach to deploying our resources, we get less support calls and more confidence in our product. More importantly, by using Puppet, we push product and infrastructure fixes out quicker and more reliably. With this consistency, all our servers have the same look and feel. There is no need to remember where installations might be when administering a server, or worry that you've chosen the correct installation option when someone is setting up something complex like SQL Server. This allows us to treat our servers like cattle rather than pets. If we can't fix a server, a member of the team can simply kill it and fill out a web page for a new one, which ARM will dutifully build and Puppet will configure while we make a cup of tea. Lastly, by doing all of these things, we've managed to reduce our costs, increase the number of environments that we manage, and become more agile.